Alright, so here comes a quick review of what we did today in class. So we talked about PPF and OC, and PPF stands for Production Possibility Frontier, and OC stands for Opportunity Cost. And we're going to look at two ways to describe production possibilities, which is either graph or a table. And then we will use both of those ways to talk about opportunity cost. So first, let's talk about PPF. If you use a graph, then you can see it as a curve that separates your diagram in two areas. So first of all, we have X and Y. So you have one good on the horizontal axis, another good on the vertical axis. And the important thing is these are both goods. It's not like they are input and output. They're both outputs, so to speak. As I said, this curve, which is production possibility frontier, separates two areas. One area that is not feasible, so everything here is not feasible, not achievable, because actually one important assumption behind this model is that the amount of resources we have is limited, and also the state of technology doesn't change. So that gives us this limit of how much stuff we can make. So yeah, you cannot break through this wall, so to speak. So, and that becomes the area that is out of reach. Everything on this curve or below is feasible, but everything below is inefficient. So if you're at this point, it means you're not using your resources, to their full extent, and you're missing on a chance to actually have more of either one good, so from being at this point, you know that in fact you can increase consumption and production of good X, or you can increase production of good Y, or you can increase production of both. So simply put, any point below the PPF is inefficient or inferior to whatever we can get on the PPF itself. And basically that means that we want to stick to PPF because we cannot be above and we don't want to be below. Next thing is to talk about opportunity cost. OC, So opportunity cost is what you have to give up to get something else. And it's very important to understand that it's not like we're talking about the amount of resources needed to make something. It's actually about both goods. So you have good X and Y, right? And given the shape of this curve, which is downward sloping, it means that to have more one good, you always have to reduce production of the other. So if you are sitting at this point where you have that much of good X and that much of good Y, and then you feel like having more of good X, which means you want to go further right. And let's say you go as far as this point. So XB. Well, the thing is that given this constraint, this PPF curve, you cannot simply go right, shift this point further right. You will have to go down to increase your production of good X. So the amount of good Y that you will lose when going down to go further right is the opportunity cost of increasing production of good X. So very important thing, opportunity cost only can be measured when you're considering those increments in production of one of the goods. Just looking at a single point right here wouldn't really help you to figure out the opportunity cost. It just wouldn't make sense. You have to consider a change in your production, and then you can measure the opportunity cost of an increase in production of one good as the amount of the other good that you're gonna lose because of this increase. The last thing we want to do here when calculating opportunity cost is to calculate the ratio of the loss to the gain. So the loss always comes on top, loss in good Y, if you're measuring opportunity cost of good X. So this is what you're gaining, divided by gain in the amount of good X. If you're calculating opportunity cost of having more of good Y, then things pretty much flip. So you're gonna lose good X, and you're gonna gain good Y, and then you'll have this kind of formula. But generally speaking, they are the same, right? It just depending on which way we go, the formula gets adjusted. All right, so like for opportunity cost of good X, to be more specific, I'll just rewrite this formula down here. Loss in good Y will be measured as YB minus YA. Gain in good X is XB minus XA. And to keep things simple, we'll just look at the absolute value. So this is it. That's how you do it. Next thing we can notice is that actually opportunity cost of having more of good X is equivalent to the slope of a segment that connects these 2 points, because this is our run, this is our drop. So drop over run is basically the slope of this section. And that makes it easier to see what's going on along this curve in terms of opportunity cost. And next thing we want to discuss is the concept of increasing opportunity cost as opposed to constant opportunity cost. So increasing versus constant opportunity cost. Let's actually start with constant opportunity cost. Well, graphically, when you have a constant opportunity cost situation, you have the straight line, which basically means that as you keep increasing your output of good X, you always sacrifice the same amount of good Y. So it's not like the opportunity cost is zero. No, it could be anything, and it's determined by slope of your PPF. But the thing is that no matter where you are, whether you're in the very beginning of this curve when increasing your output of X, or you're in the very end, like here, you see always the slope of these 2 sections are exactly the same. And that's what we call the case of constant opportunity cost. If you go back to this nonlinear PPF, then you can notice that when you're just starting production of good X, so from here where you have 0 good X, so and keep going to the right, increasing your production of good X, then opportunity cost is actually getting larger because the slope of this segment is getting steeper and steeper. So in the very beginning it's fairly flat, then it gets a bit steeper, then noticeably steeper. Here it gets real steep, and finally it gets as steep as it gets. So which means that opportunity cost of each additional increment is getting larger and larger, and that's why we call the situation the case of increasing opportunity cost. So that's how things works in terms of well, on the graphs. Next thing, really briefly, I'm not sure if it actually makes sense to write it down. So why would we have increasing opportunity cost? Or actually, when we will have increasing and when we will have decreasing, not decreasing, constant opportunity cost. So why increasing opportunity cost and why constant opportunity cost? Constant opportunity cost. Why or under what circumstances? Simply put, you'll have constant opportunity cost if the resources that you're using to produce your stuff is equally suitable for its purpose. For example, think of land. Story of land. If your land is uniform, which basically means that you have one large, let's say, lot of land, and it's all the same. It's all like grassy, nice area. Then you'll have constant opportunity cost, at least if you think in terms of producing agricultural stuff versus doing something industrial. So let's say you have this piece of land, and you can either grow stuff here, or you can build some shops. Okay, so again, if this lot is uniformly productive in terms of agriculture, then if you start from, well, doing nothing but agriculture, right? And then picking some pieces of land for your workshops, then every time you take a piece, you lose exactly the same amount of your agricultural product, right? Because all these lots you're going to take out, all these pieces, they're equally productive. So this lot is as good as this one, or just like this one. So every time you take one out of agricultural use, you're losing exactly the same amount of agricultural stuff. And that will make the case of constant opportunity cost, because each additional workshop will cost you exactly the same in terms of how much agricultural produce you will lose. If your land is not uniform, then you're likely, well, not likely, but definitely going to have this increasing opportunity cost situation. Why so? Well, again, let's say you can split it in pieces. And let's say this is the most productive, the second most productive, third, and so on and so forth. Then it's like what, 3, 4, 5. So 5, 10, 15. So we have 20 pieces. And again, they are ranked in terms of productivity. So if you're doing nothing but agricultural stuff, right, then you just make nothing but agricultural things. And then at some point you feel like, doing something industrial. So you want to build a workshop. Which lot will you use to build your first workshop? Well, clearly the least productive in terms of agriculture. So 20th piece of land. So you'll take it out and we'll build a workshop. But because this is the least productive piece, right, of land, you're probably not going to lose too much of agricultural stuff, because it's like the 20th piece in terms of productivity. Okay, but as you keep going, let's say, so you build first workshop and it didn't take too much in terms of agricultural produce, because that piece was not very productive to begin with. Then you take another one, right? So it's number 19. This piece is not super productive either, but it was more productive than number 20, right? Because they're ranked like that. So as you keep going, taking out one piece after another, you're losing increasingly more. And well, that's the way you want it to be, because you don't want to take, the best piece out of agricultural use. So that's why every time you take out a piece of land for agriculture, for industrial use, you're losing increasingly more in terms of agricultural produce. So when you used everything up and have this last piece left, right? That's the most productive, the best, the most fertile piece of land. So when you're taking this one out, you're losing the most. And that basically explains why you have this situation where your opportunity cost is rising, going up, increasing. All right, so that's the intuition behind the story. Okay, so that's the story of the diagram. Let's take a brief look at the table. So you have two columns, X and Y, and then you have A, B, C, D. These are bundles. And let's say you have 0, 50, and then 30, 0 here, and then you have 10, 48, and then you have 20, 30. So if it's the way your data is presented, then you can calculate opportunity cost applying the same formula we used here. So it's lost in one good divided by increase in another good. So if you want to go down this way, you'll be increasing your production of good X, right, and decreasing your production of good Y. Actually, if you were going this way, then it will be the other way around. But for now, let's just do the first case. So if you go from A to B, what happens? You gain 10 units of X. Actually, well, let's make it a bit shorter. So gain 10 of X, lose how much? 2 units of Y. So, and then if we calculate the ratio, opportunity cost of additional amount of X we're getting in this case is, remember, it's loss over gain, so it's 2. Well, let's write it down. Loss in Y over gain in X, so it's 2 over 10, so it's 0.2. Okay, let's do one more. If you keep going, increasing your production of good X, so you again gain 10 of good X, going from 10 to 20, lose, now you're losing 18, right? You go from 48 to 30 of Y. So now you can calculate opportunity cost of this additional increase in good X as, again, loss in Y over gain in X. And that's basically what? Same thing at the bottom, 10 and 1.18 on the top. So it's 1.8 units of good Y sacrificed per 1 unit of good X when getting more of good X. We can also do this last thing. So I'll just do it very quickly. So again, we're gaining still 10, right? Going from 20 to 30. We're losing 30 units of good Y. So it's 30, again, opportunity cost of good X, 30 over 10, 3 units of good Y sacrifice per 1 unit of good X in this case. All right, so this is how it works. And I'll just stop here. It took me like 18 minutes to cover this stuff, so I think that's enough. Again, take a look in the textbook to see how things work when we have more resources, and which basically is described as economic growth. But this is the end of my review. Thank you for your time. I hope it helped.